Given question: in a lifting machine, an effort of 500 Newton is to be moved by a distance of 20 meters to raise a load of 10,000 Newton by a distance of 0.79 meters. Determine velocity ratio, mechanical advantage, efficiency of the machine. Determine ideal effort, effort loss in friction, ideal load, and frictional resistance.
This is the question of lifting machine, and let us understand the given data with the help of wheelbarrow diagram. In case of wheelbarrow, we have to apply effort at the handle to lift the handle by certain distance. Now that effort applied is known as Fe and the distance moved by the effort is known as dE. When we lift the handle, then the load is also getting lifted by a short distance. So distance moved by load is known as dL. And the load applied, that is the load in that carton, is also mentioned in the question, and that is known as FL. So here is the given data. Fe, that is the effort applied at the handle, 500 Newton. Distance moved by the effort, that is the distance lifted by that handle, is 20 meter. Then FL, load applied, that is load will act in the downward direction, that is 10,000 Newton, and distance moved by load dl is 0.79 meter. Now first question, we have to find out mechanical advantage. So in case of lifting machine, mechanical advantage is the ratio of this load as well as effort, that is FL divided by FE. So which is equal to 20. So here Newton unit is getting cancelled and this answer is 20. Now velocity ratio. So velocity ratio is the ratio of this distance by effort divided by distance by load. That is 20 divided by 0.79, which is equal to 29. So 25. So here also meter unit is getting cancelled. Now next question is efficiency. So efficiency is the ratio of mechanical advantage and velocity ratio, that is 20 by 25, which is equal to 0.8. So efficiency we have to write in percentage, so we will multiply here with 100 and which is equal to 80%. Now next question, ideal effort. So this ideal effort is applicable for the ideal machine. Now what is the specification of ideal lifting machine? So in ideal lifting machine, this mechanical advantage is equal to velocity ratio. And why this mechanical advantage is equal to velocity ratio? Because there is no any friction. In simple lifting machine or in normal lifting machine, we have to overcome with friction, and that's why these two parameters are different. But in ideal machine there is no any friction and therefore mechanical advantage is equal to velocity ratio. So for ideal effort, that means we have to find out this term Fe. So for ideal machine we can say FEI. So FL by FEI is equal to VR. So we will first apply the rule for ideal machine. MA is equal to VR. So what is this MA? So MA, that is mechanical advantage. So here this load will remain same, but this effort we have to find out. So we will say that FL divided by FEI, because we have to find out this FEI, ideal effort, and which is equal to VR. So VR, what is the value of VR? So VR is 25. So we have to put this value. So how to find out FEI? FEI is equal to FL by VR, which is equal to 400 Newton. That means we can say that when we have to find out ideal effort, all the other parameters, that is this VR as well as FL, we have to take from the given data. Now we have to find out effort lost in friction. So in ideal machine there is no any friction, and that's why we have to take effort effort lost in friction. How to calculate? We have to take the difference for this effort in normal or simple lifting machine and effort in ideal machine. So when we take the difference, then we will get effort lost in friction, Fe minus Fei, that is equal to 100 Newton. Then ideal load. So we have to find out ideal load, that means FL term. So ideal load, that means FLI. Now in this case also, all the other parameters we have to consider as it is except this, that is from the given data. So we have to use the formula, that is FLI, then Fe as it is, and then VR as it is. So VR is equal to 25. So again we will apply this rule, MA is equal to VR. So MA, that means we will use FLI because we have to find out ideal load. FLI divided by Fe. So Fe from the given data. So FLI by Fe is equal to VR. So FLI is equal to VR into Fe, that is 12,500 Newton. So this is the ideal load. Now question is frictional resistance. So we know that for this ideal load, no any friction. So no any friction, and that's why FLI is equal to, that is this value of load is 12,500 Newton for the same machine. But when the friction occurs, then there is FL 10,000 Newton. So when we take the difference in between these loads, that is FLI and FL, then we will get the frictional resistance. Because load is what is the meaning of load? Load is the resistance, or we can say frictional resistance overcome by the machine. So frictional resistance, that means FLI minus FL, and which is equal to 2500 Newton.